Okay, so today we'll be learning about integrals. If you don't know what an integral is, it is the area of a function from point A to point B. I'll show you how this looks visually on the graph. Oops. So it's all this. We're finding this, right? And if you were put in a formula, it'll be integral from A, this part here, to B, this part here, of the function of x dx, right? So then this, well, when you solve for it, it'll give you an antiderivative. It'll give you a formula for finding the area, right? Pretend it's a random integral. So you found it. So this is now a new function, right? From A to B. Oops, forgot the C. So also always put a constant at the end of your antiderivative because your antiderivative gx plus c, when you take the derivative of it, it must equal f of x again. So I'll show that in a bit. So look, so say we have the function g of x plus c, right? And we take the derivative of it, it has to give us f of x, basically, right? Now, since we're finding the area of a function, this is a definite integral, right? A definite integral is an integral that gives us a value. We're finding something, we're finding the area of it. And then there's an indefinite integral where there are no points and you're just finding the antiderivative, which is just gx plus c. So you don't have to solve. So this is in def, and then this is just the definite. So definite integral here, and an indefinite integral here. And then let's go back to the definite integral here. And then so when we're solving, you always plug in the b first into the antiderivative. And you don't and when you're plugging it in, you don't have to worry about the c anymore. Well, honestly, because I just realized this is a definite integral, we don't have to put c. No. But if it was indefinite, definitely put the c. Mhm. Okay, so it'll be g of x, I mean not g of x, sorry, fucked up. G G of B, subtract G of A. And then you'll solve, and then I'll give you your answer. Okay? So, and now we're gonna go to the different, not law, they're not laws, they're rules, I guess, where, for instance, say you have a constant in front of your function, right? You could move the constant outside of the integral, and you just find the antiderivative. You don't have to worry about the constant anymore. So it'll just be c multiplied by gx. That's it, right? How would this look like? Example would be, let's see. Let's just do x. Oh, let's do 100 times x squared dx. And oops, accident. So you just move the 100, be x squared dx, and you just solve for the integral. So it'll be 100 times x to the power 3 divided by 3 plus c. And you just distribute it, so it'll be 100 x to the power 3 by 3 plus c. Oops, that's wrong. plus 100c. There you go. So that's one of the rules, first rule. I think this is called the constant rule. If I'm not wrong, here, let me check. Let's see. Yeah, so this is a constant rule. Just making sure. You have the constant rule, and this is the power rule. Just basically solving an integral. So we say we have function x to the power of n dx, and then if you want to solve this integral, you have x, and you add a plus 1 to the exponent. You know, whatever your whatever your exponent is, you divide by it. So it'll be n plus 1 as well. And obviously, you can't forget your constant, right? So, last one is the sum or difference rule, right? Where you have a function f of x that is being either added to another function, dx, or a function that is being subtracted. And the sum or difference rule basically just states that, you know, you take the integral of each function. So it'll be like this. It'll be integral of f of x plus the integral of g of x. Oh, can't forget the dx equals dot dot dot. You could do it. You eventually, you could figure out the rest. And then vice versa will be f of x subtract the integral of g of x. Oh, forgot my dx again. And then yeah, you can fill in the blanks, whatever, you solve for it. So yeah. Okay. So let's go to our first example. Sample one. Let's see. Let me try to think of a big integral. All the integrals I'll be solving they'll be definite integrals because obviously, like, for indefinite integral, when you just solve for that, you just solve for its antiderivative, so it doesn't even matter. I'm doing a definite integral just to show you like how it works and the work of it. Okay, so let's just say, I don't know, point A is equal to 0 and point B is equal to, let's see, let's do 2. Okay, and then the function, it's x squared divided by, let's do 5. Actually, let's do 4. Okay. So if you want to do this yourself, you can pause the video or whatever. I don't care. But basically, we could see here that x squared is being multiplied by 1/4. 0. So it'd be 1/4 times x squared dx, right? And if we go back to the different rules, this is the sum slash difference rule. This is the power rule, and this is the constant rule, which we need, the constant rule. And we see that 1/4 is the constant. Therefore, we move 1/4 out of the integral. So we 0 to x squared dx, and we just solve the integral as is. And then we go back here, and we go back to the power rule, which is this one right here. So we add 1 to the power, and we divide everything by the power. So in this case, it will be x 2 plus 1, x to the power 2 plus 1, divide everything by 2 plus 1, plus, and then you can't forget your constant, because I'll show you in a minute why. And this would equal 1/4 times x third times x to the third. I mean, divided by, it would be x to the power of 3 divided by 3 plus c, which would just give me x to the power of 3 divided by 12 plus c divided by 4. Okay, that's your antiderivative. And c is equal to, or c equals all real numbers. It could be any real number. It could be 100, it could be 1,000, it could be 2,000, it could be a million, it could be trillion, or it could be any number as long as it's a constant. Uh, and why this is important is because, like I said earlier, or I don't know if I mentioned it, but I'll mention it again. The antiderivative that we found must equal to the integral. So in this case, x to the power of 3. So for instance, say so we have the antiderivative x to the power of 3 divided by 12 plus c divided by 4. And then if you find the derivative of this, it would just be 3x to the power of 2 divided by 12 plus 0. If you don't know what a derivative is, the derivative is the slope of your function. So for instance, say you have a function that looks like this, whatever, and then this would be your slope. So, oops. So that this right here is the derivative, right? And when we simplify this, it'll be obviously x squared divided by 4. And there you go. That means that we did the antiderivative right, and that's also a different way of checking. And if you don't know what a derivative is, how to find a derivative, I'll go into it more in detail in another video, but right now I'll just be talking about integrals. I'll give you a quick example. For instance, you have the derivative x, or I mean, not the derivative, you have the function f of x to the power, f of x where it equals x to the power of 3. And then when we're finding the derivative, like I said, it is the slope of that function. So f prime, or in this case, the derivative of f of x equals 3x squared. We bring the 3 down and we subtract 1 from the exponent. So, and basically, x to the power of any n equals, when you take the derivative, equals n times x to the power of n subtract 1. That's basically finding the derivative. Okay. So let's go back. So we found the antiderivative. Now we need to find the area. And I'm putting this in brackets, 0 to 2. So when you're finding the antiderivative, when you're finding the area, sorry, always start with b. And in this case, b is 2, or the number on top of the integral, and a is the bottom one. So it'll be 0. So it'll be f g b subtract g a, or in this case, Also, when you're solving for this, you don't have to worry about the constant. To be honest, just when you're solving for the area, like just you don't have to put the constant. So you don't have to use this part in the formula. So I'll show you right now. So it'll be 2 to the power of 3 divided by 12, right? And we don't need a constant, so we don't need c divided by 4, right? Subtract 0 to the power of 3 divided by 12, right? And this is just equal. This will equal 8 divided by 12, subtract 0, which in turn is just, it's 2 to 3, 2 divided by 3. So that, yeah, that's that's the area of this function right here. That's the area of this function. And now let's move on to a different function or a different integral. And let me think. Okay, we could talk about u sub. If you don't know what u sub is, I'll show you right now. Example, well, should we do u sub? Yeah, we'll do u sub right now. Okay. Oops. So if you don't know what u sub is, you're basically just substitute when you see a integral that is really hard, or not hard, just a little bit more complex than, say, this one, right? Where there's it's a fraction, but there's the fraction contains two functions where the numerator is a function in itself and the denominator is a function of itself. For instance, in this case, let's just do 0, a equals 0, and then, I don't know, b is equal to 1. Okay. It'll be, let's see, let's stick 1, all right, 2x divided by x squared plus 100, right? So you're probably wondering, how are you gonna do this? Oh my god, it's so hard. Why are you giving me these hard problems? Stupid professor, I'm gonna beat his ass. Blah, blah, blah. Well, fuck you. You can do this problem. Stop being a little whiny bitch. So, you're looking at this, and you have to the only way for you to get better or to see it is just practice. So in this case, we make the denominator equal to x squared plus 100, or u equals x squared plus 100. So we make the denominator equal to u, right? And then we take the derivative of this new equation, du dx equals 2x plus 0. And you already know that, so we don't need that. And then you could now see like a correlation. There's 2x in the numerator right here. And then there's 2x here when we take the derivative, right? So then you can just start moving it around when you find that dx, I'm moving the dx here so it could be more easier to visualize. Think of dx, think of it as like dx being multiplied as 2x, but you're not really multiplying it by, just saying. I'm just making it like more, you can visualize it more. Where you move around, so we go back to this one, you move around the equation. So du equals 2x dx to get this same thing in the numerator, right? So now you just, like the name entails, substitute it in, u sub. So this will equal 1 divided by u equals du. That's your new integral. Oops, got that. 1, 0. So you're probably wondering, okay, this is a fraction, but at the same time, it's not, it's not something that we did originally, like here. It's still a fraction. And you're probably wondering, how many years? It's still hard. Anytime you have a fraction as an integral, whether I won't go into detail. I'll go into detail on another topic because you could take the integral with respect to a variable and it might change a certain thing when you're taking it. But right now, when you see a fraction or when you take an integral of a fraction where 1 is divided by u, it'll equal the natural log of the absolute value of u. Oops, we forgot the c, plus c. Actually, no, we didn't. You don't have to do that. The natural log u, right? And then and then you're like, okay, oh my God, hold up. Ugh. Then your 2 points, 0 and 1 will change when you're doing u sub. So u, so you just plug it in. So you plug in 0 to this new equation. So it'll be u equals 100. And then for this one, for 1, u would equal 101. So it'd be u equals 100, and then u equals 101, right? And then u du. Now, like I said before, the integral of 1 divided by u is the natural log of the absolute value of u, right? Equals 101. Whoops. U equals 100. Oh, I forgot the c. I did indeed forgot the c. Hold up, hold up. Plus c. Okay. So we have u equals 100, and then u equals 101. So now you're gonna re-plug x squared plus 100. Remember, u equals x squared plus 100. So you just plug it in again. X squared plus 100 plus c 1 u equals 100. Oh, forgot saying I did a mistake again. Because we replugged the original function back into the antiderivative, your points change back to 0 and 1, okay? And now you just solve, right? So it'll be ln 1 to the power of 2 plus 100 subtract ln 0 to the power 2 plus 100, which will just give you ln 101 subtract ln 100, or if you want to simplify even more, 101 divided by 100. Okay, so that is the area of the function where 2x divided by x squared plus 100 equals 2. Now, I'm trying to think of another integral we could solve for. Okay, I got one actually. Do I? Or I might just stop it here, to be honest. Trying to think. yeah, I think I'll just stop it here for today, and I'll continue, or maybe I'll upload a whole nother video in a couple days. But yeah, thank you guys for watching, and I'll see you soon.